Kimia. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia, sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Assalamualaikum dan salam sejahtera semua. Okey, hai semua para guru, ibu bapa yang dihormati dan para pelajar yang cikgu kasihi sekalian. Okey, selamat datang ke Pusat Tuition Akademi YouTuber Ayu, usaha sama e-didik Malaysia dan Kelab Guru Malaysia. Okey, bermula percuma, selamanya percuma. Okey, untuk mendapatkan keberkatan kelas kita pada petang ini, mari kita sama-sama mulakan kelas dengan bacaan umur kita Al-Fatihah. Okey, apa khabar para pelajar yang cikgu kasihi semua? Okey, harap semuanya berada dalam keadaan yang baik, bersedia untuk meneruskan kelas kita pada petang ini. Okey, cikgu percaya pelajar-pelajar dah tak sabar untuk mengikuti kelas pada petang ini. Okey, cikgu perkenalkan diri dahulu. Okey, nama cikgu Cikgu Nik Mawar Hanifah binti Nik Hassan, okey, atau Cikgu Mawar Kimia dari Kuantan Pahang. Okey, selaku moderator pada petang ini. Okey, hari ini kita ada kelas tuition kimia Prayu. Okey, pada petang ini juga kita bersiaran secara langsung dari channel Teacher Tang. Okey, sesiapa yang belum subscribe Teacher Tang, silalah tekan butang subscribe sebagai tanda sokongan kepada Teacher Tang. Okey, untuk maklumat semua pelajar, okey, cikgu nak perkenalkan diri kita punya presenter iaitu Teacher E. Yuntang dari Kolej Matrikulasi Selangor. Okey, tajuk yang akan disampaikan oleh Teacher Tang pada petang ini ialah Hydrocarbon, iaitu Free Radical Substitution. Okey, khas untuk pelajar kimia STPM semester 3. Okey, atau pelajar matrikulasi semester 2. Okey, pelajar dan para penonton lain juga dialu-alukan untuk mempelajari topik berkenaan. Okey, kelas ini akan berlangsung lebih kurang 1 jam. Okey, dan bersama dengan cikgu di studio pada petang ini juga ialah Cikgu Syahnon. Okey, Cikgu Syahnon mengajar kimia matrikulasi dari Kolej Matrikulasi Pulau Pinang sebagai control host. Okey, dan Cikgu Syahnon juga merupakan KP bagi tim Kimia Ayu ya. Okey, bersama kita juga pada petang ini ialah Cikgu Kong. Okey, Cikgu Kong mengajar di Kolej Matrikulasi Perak. Okey, bertindak sebagai pemerhati pada petang ini. Okey, sebelum kita meneruskan kelas kita, okey, cikgu cikgu nak ingatkan iaitu semoga semua pelajar dan penonton yang ingin menghantar komen agar menggunakan bahasa yang sopan, gambar profil yang bersesuaian untuk tontonan umum. Okey, sila fokus pada isi pelajaran yang akan disampaikan dan hanya menggunakan ruangan chat untuk menjawab soalan atau jika ada soalan yang hendak diajukan. Okey, pada akhir siaran ini, link e-sijil akan diberikan dan anda hanya ada 30 minit sahaja untuk mengisi maklumat. Okey, pastikan menggunakan email e-didik sahaja. Okey, cikgu percaya semua yang hadir pada petang ini merupakan pelajar yang cemerlang. Okey, mari kita tunjukkan disiplin yang terbaik. Okey, cikgu harap semua dapat memberikan sepenuh perhatian sepanjang kelas ini bersiaran. Okey, tanpa membuang masa, okey, cikgu serahkan kelas kita kepada Teacher Tang. Okey, dipersilakan.
From College Matrikulasi Selangor, I have 8 years of experience teaching chemistry. So with me, the chemistry Prayu team. So we have the collections of the PDPC video. So you can go and watch our videos. So with me in the chemistry team, we are led by Cikgu Shannon, and then me, Cikgu Mawar, Cikgu Bibi Lau, Cikgu Kong, and Miss Madeline. Okay, so this is Team Prayu chemistry IU. Okay, so beside the chemistry team, we also have the pre-U mathematics team led by teacher Ying. So the members are teacher Eileen, teacher Zana, and others. And for the biology team is led by Cikgu Faiza. So have Cikgu Wawa, Cikgu Naini, and also Cikgu Fatia. And then beside the bio, we also have the physics team. So led by teacher Ying. So physics team also have their videos. So you all can go have a look on the videos. And we also have the accounts and economics team. So led by Madam Fizi. So the members are Cikgu Yati, Cikgu Lee, and Cikgu E. So then now I continue with our topic this afternoon on alkanes. So we are going to look at the chemical properties of alkane. So for alkane, alkane, they all can be combusted with oxygen. So depends on the amount of oxygen. So if excess oxygen, then we will get carbon dioxide and water. So if limited oxygen, then can get carbon monoxide, carbon, and water. So, but for this afternoon, instead of focusing on combustions, I will be focusing on the free radical substitutions reactions of alkane. So this is alkane. So for alkane, so generally alkane is inert. Why alkane is inert? So alkane is inert because the carbon and hydrogen have similar electronegativity. Okay, so because carbon and hydrogen have similar electronegativity, that's why the carbon and hydrogen bond is only slightly polar. It's only slightly polar because carbon and hydrogen have similar electronegativity. Alkane also do not attract electrophile or nucleophile. Okay, so that's why alkane generally is inert. Though alkane is generally inert, okay, but alkane do undergo a type of reaction, and the reaction that alkane undergo is free radical substitutions reaction. Okay, so we are going to look at in detail what is free radical substitutions reaction that alkanes can undergo. So for type of reaction that alkane can undergo is free radical substitutions reaction. But the name of the reaction is halogenations. So it's just like cooking. Okay, cooking. So the cara masakan goreng nasi, so it's called nasi goreng. So for alkane as well, the type of reaction is free radical substitution. So it depends on apa benda yang digunakan untuk substitute the hydrogen in alkane. So in alkane, halogen is being used to substitute the hydrogen of alkane. Therefore, the name of the reaction is called halogenation because the hydrogen diganti oleh halogen. Okay, so it depends on the halogen. If it is bromine that is used to do the free radical substitution, then we call it as bromination. If chlorine is being used to do the substitution, then we call it as chlorination. So the name of the reaction is depend on which halogen that is being used to do the free radical substitutions reaction. But overall, the type of reaction is still free radical substitution. Depends on which halogen used to do the substitution to determine the name of the reaction. Okay? So the general reaction, so this is your alkane. So in free radical substitution, hydrogen of the alkane is being substituted by the halogen. And this halogen can be chlorine, okay? So to this hydrogen will be substitute by chlorine or bromine to give you the product. So this is the product. And this is HX is the byproduct, or we call it as the side. Basically, we'll explain in detail why we need UV or heat for this reaction. So for free radical substitutions reaction, so we have alkane, so both are alkane. We fill in the test tube. So remember, to do the free radical substitutions reaction, the hydrogen need to be substituted by halogen. So I put in the halogen. So here I put bromine. Okay, I put bromine. And then one I place in dark. Okay, so put in the cupboard. Another one place under the sunlight. Place under the sunlight. Okay, so after 1 hour, okay, so we can see that the one placed in dark is still reddish brown. So it's still reddish brown. So it's still reddish brown means that the bromine that I added not successfully replaced the hydrogen in alkane. But if it turns colorless, the reddish brown of bromine turns colorless, means that reactions has occurred. Reactions has occurred. Di mana the hydrogen of the alkane has been substituted by bromine. So what does this imply? This basically implies that for the free radical substitutions reactions of alkane require sunlight, UV, sunlight, or heat. Okay, so why heat or sunlight is required in the free radical substitutions reaction? It is because with the presence of Okay, so with the presence of sunlight or heat, okay, so energy is being provided, and this energy basically is needed for homolytic cleavage of halogen molecule. So this halogen molecule, in order to start the reaction, the free radical substitutions reaction, so UV or heat is needed to break the covalent bond of the halogens. Okay, so break the halogen homolytically in order to produce the free radicals of halogen. And these free radicals of halogen is needed to start the free radical substitutions reaction. Okay, that's why for the free radical substitutions reactions, you need to put it under the sunlight or heat it up, because you need the energy to break the halogen, the covalent bond in halogen homolytically to produce the free radicals. So just now I already mentioned, for the free radical substitutions reaction, the halogen that we use can either be chlorine or bromine. Okay, in general, bromine is less reactive than chlorine to do the free radical substitutions reaction. However, bromine is more selective than chlorine. So for bromine, majority of the product will be the more stable. Okay, we are going to look at this in details. So basically, for halogenations of alkane, okay, so in the matriculation syllabus, you all are learning mono substitutions of alkane with halogen. So only one hydrogen of your alkane will be substituted by halogen. Okay, so to determine the products, so basically we need to look at the alkane. Okay, we need to look at the alkanes, whether the alkanes has equivalent hydrogen or the alkane has a non-equivalent hydrogen. So if alkane with equivalent hydrogen, we will only get one product. But if the alkane with non-equivalent hydrogen, then chlorinations and brominations will give mixture of products. Okay, will give mixture of products. So, for example, so alkane with equivalent hydrogen. So in methane here, all these hydrogen are the same. So when all these hydrogen are the same, we say this alkane has equivalent hydrogen. Okay, so when we have hydrogen, then we only get one mono-substituted product. One mono-substituted product. Bermaksud satu hydrogen sahaja akan diganti oleh halogen. So you get this as your product. And of course, the byproduct is a HCl. So you get only one product. You get only one product because the alkane is with equivalent hydrogen atom. I told you already just now, HCl is byproduct, not product. Okay, product is referred to this. So equivalent alkane with equivalent hydrogen, so you only get one product. Okay, so it doesn't matter the Cl is replacing this hydrogen, this hydrogen, this hydrogen, or this hydrogen. Okay, so the product will be the same. The product will be the same. So you get one hydrogen. So like for this alkane as well, can you see that this is primary carbon? So this is primary carbon. So the hydrogen that attached to it will be primary hydrogen. So this is primary carbon, so primary hydrogen. So primary hydrogen, because they all attached to the primary carbon. Can you see that all of these hydrogen, they are equivalent as well. They are equivalent as well. So if equivalent, bermaksud in the mono substitution reaction, doesn't matter mana satu hydrogen being replaced. Okay, so you will only get one product. You will only get one product. Okay. So example, if one of these hydrogen being replaced, so you get this as your product. Okay, and the byproduct HCl. Again, doesn't matter. So this 1, 2, 3, 4. So these 12 hydrogen, they are all equivalent. They are all equivalent. So means that doesn't matter Cl is replacing this hydrogen, this hydrogen, this hydrogen, or this hydrogen, same products. So again, alkane with equivalent hydrogen, you get one product. You get one product. So how about non-equivalent hydrogen alkane? So for non-equivalent hydrogen alkane, you get mixture of products. Okay, you get mixture of products. For chlorination, okay, so the major and the minor products basically about the same percentage, Okay, so and then which one is the major or minor products? It depends on the stability of the free radical. So in the previous chapter, you have remember the carbon with unpaired electron is electron poor. So when more alkyl group attached to the carbon with the unpaired electron, more stable is the free radical. So the tertiary free radical has 3 alkyl group. So it is more stable compared to secondary free radical, and which is more stable than the primary free radical. Okay, so means that the free radical, tertiary free radical is more stable. So more stable is the free radical, then the product formed from that particular free radical is going to be the major product. So major product from free radicals. Okay, so minor product is from the free radicals that are less stable. Okay. So for example, can you see that this alkane propane is having non-equivalent hydrogen? Okay, so having non-equivalent hydrogen. So you can see that this hydrogen is primary hydrogen because attached to primary carbon. And this hydrogen is secondary hydrogen. And this hydrogen is primary hydrogen. Okay, so if secondary hydrogen, okay, so two different environment of hydrogen. So this primary hydrogen, same environment, okay, and this secondary hydrogen, so different environment from the primary hydrogen. Because of that, two mono-substituted products you will get. Two mono-substituted product you will get. Okay, so the substitution can occur at the primary hydrogen. So if occur at the primary hydrogen, then your product will be, so satu hydrogen sahaja diganti. So if ganti dekat primary hydrogen, then you will get this, the primary hydrogen. It can also substitute at the secondary hydrogen. One of the hydrogen on the secondary hydrogen being substituted, then you will get this product. Okay? So which product is major? So remember, major must be from the more stable free radical. Must be from more stable free radical. Okay, so shall we draw the free radical? So the primary hydrogen, then the intermediate, primary intermediate, the intermediate we are going to get is this. So this is primary free radical. Remember, this is your reference carbon. So having one alkyl group. Aya?
Your line is a bit laggy. Ada line, your line ada on off sikit. Line. Your line is ada tak berapa okay.
Yes.
Okay, just continue je. Tadi dia ada macam on off suara you.
Cikgu Mawar?
Hello, dengar tak?
Ya, Cikgu Mawar?
Tadi you punya line ada on off sekejap.
Oh, okay. Oh, my line is not very okay.
Okay.
Oh, okay.
You just continue.
Sorry about. Boleh dengar. Oh, okay. Sorry about that. Ya, sebab hujan. Okay. So sorry about that. Okay, good. Shall we continue? Oh, okay. So if the substitution occur at the secondary hydrogen, so the intermediate that we are going to get will be this. So will be this. Okay, so this is the reference carbon. So only one hydrogen bermasuk two alkyl group. So having two alkyl group. So this is the alkyl group. So this is the alkyl group. So have two alkyl group. So this is the secondary free radical. So can you see that this product is from the secondary free radical, which is more stable. So therefore, this is the major product. While this product is from the primary free radical, which is less stable. Therefore, okay, and of course, since I'm writing the equation, don't forget to put the side product or byproduct. So, but product, we are still looking at this, the major and the minor product. So, for alkane with non-equivalent hydrogen, we will get mixture of product. We'll get minor and major products. Okay? So, another example. So, now we move on to look at brominations first. So, for brominations as well, okay, you will get mixture of product, major and also the minor. Okay, so because this is again propane, so I already told you propane, the hydrogen is non-equivalent. So this is secondary hydrogen, this is primary hydrogen. So substitution can occur at the primary hydrogen where satu hydrogen diganti oleh bromine. So satu hydrogen diganti oleh so you can get this as your product. And then if the substitution, mono substitutions occur at the secondary hydrogen, then you get this product. And then the one from the secondary free radical, therefore, this is the major product, while this is the minor product. Because from the less stable primary free radical, and the byproduct here is HBr. Okay, so later on I will talk in detail when we look at the mechanism. So to summarize, for mono substitutions of alkane, how do we determine the product? So we just need to look at the alkane. So if you are having, so you just need to ask yourself, the alkane, whether having hydrogen that is equivalent. So if the hydrogen is equivalent, means that semua hydrogen sama, then you get only one product. Okay, so if the hydrogen is not the same, then you are having alkane with non-equivalent hydrogen, then you get mixture of products. Doesn't matter it's chlorinations or bromination, you will get mixture of products. So now we move on to look at exercise. So look at this. So how do we know whether this alkane is equivalent or not? So we class all the carbon. So can you see that this is primary? So means that this hydrogen is primary hydrogen. So primary hydrogen. So this is secondary, and this is primary. So this is primary. Can you see that all these 9 primary hydrogen, they are the same. These 3 are the same. So means that doesn't matter substitution occur at any of these 9 hydrogen will give you same product. Okay. So however, this hydrogen berbeza. This is secondary, and this primary hydrogen berbeza from these 9 hydrogen. Therefore, you will get 3 different brominations product. Okay. So if substitutions occur at any of the 9 hydrogen, then you will get your product so for example occur at this. So one of the hydrogen, you learn mono substitution, so one of the hydrogen diganti by Br. So this will be your product, okay? And this is non-equivalent alkane because you have primary hydrogen and also a secondary hydrogen. So if occur at the secondary hydrogen here, then you will get this product. Remember, only one hydrogen being substituted. Only one hydrogen being substituted. So you get this product. Okay? So if occur at this hydrogen, so you get this as your product. And the side product is again HBr. So if product only refer to this. So which one is your major and which one is your minor? So must remember the primary free radical is less stable compared to the secondary. So means that substitution occur at the secondary hydrogen will be the major product. And the other two will be the minor product. So this will be minor. So this will be the minor product.
Teacher Tan, can you hear me?
So basically how many products that you get depends on how many different environment of hydrogen. Like in this question, this alkane, you have 3 different environments of hydrogen, so you get 3 products. So another example, so for this, so how many different environment of hydrogen can you use? Okay, so to know that, first you need to class your hydrogen. So this hydrogen, the carbon is primary carbon, so this is primary hydrogen. So this is also primary hydrogen, and this is secondary, so this is tertiary hydrogen. Ya?
Teacher Tan?
Ya?
Okey, you baru dengar. Okey, kita beri laluan kepada iklan sekejap ya.
Ya, can you hear me? Cikgu Mawar, can you hear me?
Alah, apa ni? PKPB lagi. SPM pula ditangguhkan. Jenuhlah nak bayar yuran tuition. Pernah dengar tentang tuition percuma? Kami di Akademi YouTuber menyediakan tuition online secara percuma kepada anda semua. Ada prasekolah, sekolah rendah, sekolah menengah, SDPM juga untuk matrikulasi. Percuma je. Jom layari laman sesawang www.academyyoutuber.com.
Okay, Teacher Tan. Okay, you can continue for the exercise 2. Kita tak dapat dengar suara Teacher Tan lah.
Okay, so continue.
Okay, alright, you can continue.
So for the exercise 2, so can you see that there are 2 different environment of hydrogen? So these 2 hydrogen, same environment. Hello tak? Hello, boleh dengar?
Okay, now okay, you can continue.
Okay, the line is very bad. Okay, so here we have two. Okay. Okay, wait.
Or teacher Nanya, or you can stop your cam.
Uh, okay. Wait, I stop my camera for.
Okay, you can try adjust first.
Okay, wait, some technical problem. Okay. Sorry about that. So we will at exercise number 2. Okay. Okay. So can you see that?
Okay, now can you just like show it? All right.
Okay, sorry about that. Okay, so for exercise number 2, so there are two different environments of hydrogen. So this hydrogen, they are primary hydrogen, while this hydrogen is a tertiary hydrogen. So two different environment of hydrogen. So how many products you will get, class? So how many products you will get? Okay, so we are expected to get two different products. Okay, two different products. So if occur the mono substitutions reaction occur at primary hydrogen, then we will get this product. Salah satu diganti, so we will get this product. Okay, so if the substitutions reaction occur at this hydrogen, then we are expected to get this product. Product, of course, is the HCl. Okay, so which one is the major product? So substitution at the tertiary hydrogen will give you tertiary free radical, which is more stable than the primary free radical. So therefore, this will be the major product. While this is the minor product. Okay, then now we move on to look at exercise number 3. Maybe you can do it yourself. So we move on to look at the ring one. Okay, so for the ring one, so how do we determine how many different environments of hydrogen? Okay, so also the same thing, we class the hydrogen first. So this hydrogen is primary because this is primary carbon. So, and the carbon here also have one hydrogen, and this carbon has 3 carbon friends. So therefore it's tertiary carbon, and the hydrogen here is the tertiary hydrogen. Okay, and then these 2 carbon, and in the ring, so we need to divide the ring symmetrically. Okay, from the substituent, the carbon that attached to the substituent, we need to divide the ring symmetrically, and then this carbon is going to be same with this carbon. Okay, and this carbon is going to be same with this carbon. Okay, and this carbon, the one that I circle, is consists of two hydrogen. So two covalent bond, so two more for hydrogen. So therefore, this is secondary hydrogen. So here is also secondary hydrogen. And here, two covalent bond, so two more for hydrogen. So this is also secondary hydrogen. So how many different environments of hydrogen? So 1, 2. So these two, the one that I circle are the same. So 3, and the one that I tick are the same. So 4 different environment of hydrogen. So we will expect to get 4 mixture of products. Okay, so if substitutions reaction, mono substitutions reaction occur at primary hydrogen here, then we are expected to get this product. Okay, so if the mono substitution, they are expected to get this product. If occur at this, so the one that I circle, so these 4 hydrogen, they are the same. So substitution, mono substitutions occur at any of these 4 hydrogen will be the same. Therefore, if substitution occur at any of the 4 carbon, so any of the 4 carbon is going to give you this product. Okay, and if the substitutions reaction occur at this 4 carbon, any of the 4 carbon, then you are expected to get this product. Okay, and the byproduct is HCl. Okay, so this is for the ring. So now we move on to look at mechanism. Okay, so this is chemical equation. So this is chemical equation. In chemical equation, we see reactant and also the product. Okay, we see reactants. Then what is reactions mechanism? What is reaction mechanism? So basically, reactions mechanism show step by step apa berlaku in each step of the reaction, and then also show in detail which bond need to break first and which bond need to be formed, okay, throughout the reaction, and then how the relative positions of atoms are changed in the reaction. Okay, in reactions mechanism, we see in detail which bond break dulu, which bond then will be formed, and so on. Okay, but in chemical reactions, we do not know. We only know what is the reactant, what is the product. But in reactions mechanism, we see in detail which bond break first, and then which bond will be formed. Okay, the sequence of them. So before we look at the free radical substitutions reaction mechanism, we need to practice first. Okay, we need to practice first. So in free radical substitutions reaction, the bond will break homolytically. So what does homolytic bond breaking means? So means that the single covalent bond will break symmetrically. So we know that in Cl, single covalent bond with another Cl. So this single covalent bond basically refer to the dual electron shared between these two atoms. Okay, and what is homolytic bond breaking? Means that the bond will break symmetrically. So what does symmetrically mean? So means that after bond breaking, after this bond breaking, so each of these chlorine atom will get their share, will get their share equally. So these two electrons at first share between them. After bond breaking, each of them will get 1. Each of them will get 1. So this is what meant by homolytic bond breaking, where this covalent bond break equally And then after break, each of the atom will get their share equally. Get their share equally. And then how do we use the arrow to represent this? Okay, we are going to use half-headed arrow. Half-headed arrow to represent pergerakan satu elektron. Pergerakan satu elektron. Can you see that this electron at first is shared? After bond breaking, it will be picked up by this chlorine atom. So how do we draw that? So we draw it from here, go to this chlorine. And then another one, go to this chlorine. Then only we will get this. So this is how we draw homolytic bond breaking. Okay? So, and then must remember homolytic cleavage or homolytic bond breaking. So one single covalent bond breaks symmetrically and give you free radicals. So these two species are free radicals. So how to draw the homolytic bond breaking? We draw arrows pointing away from the bond. So here is the bond. So pointing away from the bond. So pointing away like this. So satu line ini means that there are two electrons in it. Two electrons in it like this. Draw the arrows from the bond to the atom. From the bond to the atom. So that is how you draw homolytic cleavage. And then how do you draw bond forming? So bond forming means that you want to get the electron, these two electrons come together, they share like this. Or you can draw like this. So how can you draw bond forming? So basically, from the electron, you draw pointing together. Bonding together means that one single covalent bond is being formed. Okay, by bringing the two electrons together. So how to draw bond forming? So you draw arrows from the electron pointing towards one another like this to show bond forming. Okay, so in the free radical substitutions reaction, so basically there are three steps. Okay, so the free radical substitutions reaction mechanism for alkane consists of three steps. So in step number one is initiation. So initiate means start. So this is free radical substitutions reaction. Untuk mulakan the substitutions reaction, we need to have the free radical. So basically, step number one, initiation reaction, we are forming the free radicals. So how to form the free radical? By bond breaking. So by bond breaking. So which bond to break? So here, this is our reagent. We have carbon and hydrogen, also chlorine and chlorine. So which bond is the weakest? So basically it's chlorine and chlorine bond, the weakest. So this covalent bond is the weakest. Why? Because chlorine, period 3, size besar. So means that this bond is the longest, because chlorine size besar compared to carbon and hydrogen. That's why this bond is the weakest. So initiation will break the weakest bond. So where is the weakest bond? Is the chlorine-chlorine bond. So how do we draw that? So basically, chlorine and chlorine bond will break. So how to break this? We need this UV. So UV light provide energy to break this. So homolytically means that here two electrons, one will go to this Cl atom, another one will go to this Cl atom. So to give us two free radicals of, okay? And must remember that what is the functions of UV here? So basically for homolytic cleavage of halogen to produce the free radicals of chlorine. Okay, and the bond will break homolytically. So in the initiation step, basically involve bond breaking to produce free radicals. And then in step number 2, propagation. So in the first step, we get the free radicals already. So this free radical then will react with the alkane, will react with another. So after the first step, we get the free radical chlorine. And it will react with the alkane. It will react with the alkane. So which bond to break? So basically in propagation step, so occur simultaneous bond breaking and bond forming. Means that bond breaking first and then between the species. So in alkane, so can you see that substitutions occur at this carbon? One of the hydrogen at this carbon telah diganti oleh Cl. So means that one of the hydrogen here, okay, is being substituted by Cl. So means that one of the carbon hydrogen bond here must break. Okay, again, free radical substitutions reaction. So homolytic bond cleavage. Okay, so they need to break homolytically. So how to break? So again, from the bond point to the carbon. And another one will be go to hydrogen. But the hydrogen will use the electron, the unpaired electron, to form bond with chlorine. Therefore, what do you get? So you get, so Cl here have one electron and hydrogen bagi satu electron. So therefore, form one covalent bond. Okay, like this. And then you get these free radicals. Okay, and then haven't finished yet. Okay, after the propagation step, we should get the product. We haven't got the product. So we get the free radical of alkane. This free radical of alkane then will react with chlorine. Again, this is still propagation step. In propagation step, bond breaking and bond forming occur simultaneously. So how to draw bond breaking? Again, I told you already. So from the bond, go to the atom. Okay, from the bond, so supposedly go to this chlorine atom. But this chlorine atom, instead of get the electron, it will use the electron to form bond with this carbon. Okay, then you get the product. And the free radical. So can you see that in the first step of propagation, you get your byproduct. In the second step of propagation, you get the product. Okay, and this free radical basically is going to fit into this step and continue to react with more alkane to produce more alkane free radical. And then this free radical of alkane will continue to react with Cl2 to give more product. And it will go on and go on and go on. That's why this step is called propagation. Keep on propagate to get more products and free radicals. Okay, then now we move on to look at termination step. So termination step basically involves bond forming to slow down the reaction. Remember in the propagation step, we have seen we need the free radical to make the reaction continue to make more product. Okay, so then termination, terminate means stop. So how can we stop this free radical substitutions reaction? By kill the free radical, by killing off the free radicals. So in the previous reaction, we have seen this is the free radicals that we get in the reaction. Okay, so if we want to slow down the reaction, means that we need to kill off this free radical. We need to kill the free radicals. So how can we kill the free radicals? So by use out the free radicals. So how can we use the free radical? By let the free radical react with one another. Then we can slow down the reaction. So termination step involve bond forming. So how to draw bond forming? So arrow from the electron point together. Then you get the covalent bond being formed. The reactions will slow down and then stop. So beside chlorine free radical, we also get the alkane free radicals, right? So we get this. And also radicals to react with one another as well.
Teacher
So in
Tang, you
termination
have
step, can you see
3
that you
minutes
don't produce
more.
free radicals? So it's okay, almost finished. Okay, so if you don't get free radicals anymore, so means that the whole reactions will be slowed down at first and then stop. So so just to summarize, so initiation step, so bond breaking. So bond breaking. So you get the free radicals and will react with the alkane. So here is the carbon hydrogen bond that will break. So homolytically, so carbon get the part and the hydrogen will use the electron to form bond with chlorine. So you get simultaneous bond breaking and bond forming. And then this alkane free radical, okay, then will react with chlorine. So again, simultaneous bond breaking, bond forming, then you get the product with more alkane to give you more products. So in the termination step, so basically bond forming, so the arrow pointing together, like this. So as no free radical being produced anymore. So these questions, you can try it yourself and then we will discuss in the class maybe. Okay, so basically that's it for today. Thank you, class.
Okay, thank you Teacher Tang atas perkongsian ilmu yang sangat bermanfaat. Okay, dan harap mudah difahami. Okay, tahniah juga diucapkan kepada semua pelajar yang setia mengikuti kelas kita pada petang ini dari awal sehingga ke saat inilah. Okay, sebelum kita menamatkan sesi siaran langsung, okay, sila tutup ruangan chat dan klik butang subscribe yang masih merah dan aktifkan ikon loceng, okay, supaya para pelajar tidak terlepas sesi kelas yang seterusnya. Okey, sekiranya anda suka dengan apa yang dipelajari pada hari ini, sila klik like, share kepada rakan-rakan di media sosial anda. Okey, FB, Insta, untuk sebarkan ilmu. Okey, semoga kita beroleh kebaikan melalui perkongsian tersebut. Okey, sila type dan di ruangan komen. Okey, sebelum link sijil akan diberikan. Okey, dah ada ke link sijil? Okey, kita tengok okey, dah ada link sijil, dah ada di sana. Okey, link sijil sila ambil perhatian, link tersebut akan tamat tempoh setengah jam selepas live ini. Okey, pastikan anda guna email e-didik. Okey, sekali lagi cikgu ucapkan terima kasih kepada Teacher Tang dan Cikgu Shana juga Cikgu Teacher Kong. Okey, jangan lupa juga untuk dapatkan jadual tuition online terkini melalui portal www.academyyoutuber.com. Okey, serta dapatkan info terkini. Okey, bantu cikgu untuk sebar luaskan kelas tuition percuma ini kepada rakan-rakan, kepada guru seluruh Malaysia. Okey, semoga kita mendapat manfaat daripada kelas-kelas yang dijalankan. Okey, ingat hashtag bermula percuma selamanya percuma insyaAllah setakat ni. Okey, terima kasih kepada semua. Okey, segala yang baik daripada Allah. Jika terdapat sebarang kekurangan dan kelemahan adalah daripada kami. Okey, kelas tuition online percuma berakhir sudah. Okey, di lain siaran kita berjumpa lagi. Assalamualaikum dan salam sejahtera.
COVID-19 semakin menular. Sekolah-sekolah terpaksa ditutup. Bagaimana dengan nasib pendidikan anak-anak kita? Sebagai ibu bapa, kita pastinya mahukan yang terbaik untuk anak-anak. Tetapi, mengapa bebankan diri dengan kelas tuition yang berbayar sedangkan ada yang percuma? Akademi YouTuber Malaysia, inisiatif dari e-didik dan Kelab Guru Malaysia, membawakan anak anda kelas dalam talian secara percuma, secara langsung oleh guru-guru dari seluruh negara.
Dibawakan kepada anda oleh Akademi YouTuber.